Okay, so 12.3, early payoff of loans. Textbook discusses the use of the United States rule for early payment. It is common for payment to be made on a loan before it is due. This may occur when a person receives extra money or refinances a debt at a lower interest rate somewhere else. Prepayments of loans are discussed in this section. The United States rule used by U.S. governments and most states and financial institutions require any loan payment to first be applied to the interest owed, and then the balance of the payment is then used to reduce the principal amount of the loan. We will continue to use the 360-day years in the calculations of this section. So when we're using the United States rule, we'll go ahead and find the simple interest due from the date the loan was made until the date the partial payment is made. Use the formula I equals PRT. We're going to subtract the interest from the amount of the payment. Any difference is used to reduce the principal. And then treat additional partial payments in the same way, always finding interest on only the unpaid balance after the last partial payment. Then the remaining principal plus interest on this unpaid principal is then due on the date of the loan. On August 14th, Dr. Jane Ficker signed a 180-day note for $28,500 for a used X-ray machine for her dental office. The note has an interest rate of 8% compounded annually. On October 25th, a payment of $8,500 is made. Find the balance owed on the principal after the payment. And then B, if no additional payments are made, find the amount due at maturity of the loan. Okay, so 180 days, that's like half of a year for $28,500. She's borrowing it for 180. You can think of that as maybe 6 months. This is an interest rate of 8% compounded annually, right? And the date she borrowed it on August 14th, but then on August 25th, she made a payment of $8,500. So she made a prepayment almost. She's paying it, some of it sooner. There's no requirement to do so, apparently, but she went ahead, had some money. She wanted to go ahead and pay that down so that she didn't end up paying as much of interest as she continued to keep it unpaid for the entire period. So the first thing we need to do is figure out, okay, so August 14th, she borrowed the money, and I guess at this point in time, she wants to make a payment on October 25th. So we need to figure out how many days are there between August 14th and October 25th. Now you can use the months, the time. This is something we've covered in previous chapters. Go back, there's a table we could use, the number, what day is that number, what number is that day on, and what number is that, but you can compute that out. And so between August 14th and October 25th, there is 72 days, okay? If we have 72 days between those two periods, then we're going to use I equals PRT. I equals P. P is the principal, the $28,500. That's what she borrowed. Times R, it's 0.08. 0.08 is the 8%. And we're going to multiply that by the 72 divided by 360. They told us at the beginning of this chapter to always use 360. If we take 28,500, multiply by 0.08, and then multiply it by 72 over 360, I equals PRT, we get $456. So think of it this way, between August 14th and October 25th, she has accrued, or she now owes to that date, $456 of interest. So when she makes that payment of $8,500, that has to be divvied up between how much of it is going against interest and how much of it is going against the principal. So to figure out how much is applied to the principal, well, we already know the interest. The interest amount is $456. we're going to take the $8,500, that's the total payment, and we're going to subtract from that the interest that was accrued, $456. Okay, so $8,500 minus the $456 leaves $8,044. That amount is going to be applied against the principal. So after making that payment, we're going to take the $28,500 that she borrowed and subtract, not the total amount, because some of that went towards interest. We're going to subtract just the amount that went towards the principal, which is $8,044. $28,500 minus the $8,044 leaves a balance due on that date of $20,456. If 5 minutes later she decided, oh, well, I'm going to pay this off completely, all she would owe is $20,456 on October 25th. Now, the next question is, if the no additional payments are made, find the maturity amount due at the end of the loan. Well, she lowered the principal balance midstream. So now we have the balance as of October 25th. So we're going to take from October 25th all the way to the maturity date of, well, we don't even know what date it is, but it doesn't really matter. It's 72 days. That brought us all the way to October 25th. And we know it's a 180-day loan. So we're going to take $180 days. We'll take the 180 days and we'll subtract 72 days from it, because that's already gone. It's been used up. That's as of October 25th. Those days have been, they're used up. So how many days are remaining? 180 days minus the 72. That means she has 108 days remaining in this loan. Now with that, now that we have the days, we can then recompute how much the interest is going to be for the remaining number of days. She's going to start off with $20,456. $20,456. She's going to multiply that by the same 8%, 0.08. But now she only has 108 days remaining of the 360 days in a year. 20,456 multiplied by 0.08 multiplied by 108 divided by 360, and that leaves $490.94 in interest. So we're going to take this amount, that $490.94, we're going to add it to the 20,456. This is wrong in the textbook. It's saying to subtract the 490. That would not be the case. You would take the 490.94. You're going to add that, because that's the amount of interest that's been accrued for the 108. You're going to add that to the balance of 20,456. So the right answer would be 20,456 plus 490.94. So at maturity, she will have to write a check for $20,946.94, not what they came up with. I'm sure the rest of the problems are correct, but just so that we know, that you need to add that, not subtract it. Okay, finding the interest paid and the amount due. That's the way our cows look, huh? On March 1st, Boston Dairy signs a promissory note for $38,500 to replace some milk equipment for their Holsteins. The note is for 180 days at a rate of 10%. The dairy makes the following partial payments: $6,000 on June 9th, $3,500 on July 11th. Find the interest paid on the note and the amount due on the due date of the note. So this is an identical problem to the previous, with the exception that instead of just one payment, there are two payments. And every time we make a payment, we have to recompute how much the interest is going to be, or how much of that total payment is going to be applied to interest. So let's do that. The first partial payment is on June 9th, reminding ourselves that it was issued on March 1st. And it's like a 6-month loan, so there's quite a bit of time. March 1st, so we're talking March, April, May, June, July, August. So it's actually going to be due it's actually going to be due in September. March, April, May, June, July, August. Yeah, at the end of August. All of August would apply as well. So September 1, so to speak. Somewhere close to that if it's 180 days. All right, so they made a partial payment on June 9th and then another partial payment on July 11th. So what's relevant now is how many days are between March 1st and June 9th? Well, we'll figure that amount, let's see, March 1st, there's 31 days in March, but you already used up one. So 31 minus 1 gives us 30. So that's March, April, May, and June. 30, 30, 31, and 9. We're going to add these all up, and we're going to come up with 100 days. So on June 9th, that's 100 days, we have to figure out how much interest has been accrued or how much is owed as of June 9th. So we'll take the 38,500, that's the amount that was borrowed. We're going to multiply it by 0.10, that's the rate, the 10%. I equals PRT. PRT is the 100 days divided by 360. That gets us all the way to June 9th. And that computes out to be $1,069.44. Now, she made a payment of $6,000 on June 9th, $6,000. So what we're going to do is say, okay, of the $6,000, $1,069.44 is going to poof, it's going to disappear, it's going to go towards interest. The remaining balance goes against the principal. 4930.26 goes towards the principal. So we know that the principal started off to be 38,500. We're going to subtract from that this payment portion of principal, 4930.56, and that's going to give us a new balance as of June 9th of 33,569.44. Okay, so that takes care of the first payment. The next payment was made on July 11th for $3,500. So we're looking for the number of days between July 11th and June 9th. Well, let's see. We were on June 9th. That's what we were on. And so in June, there are 30 days in June. We're going to take the 30 and subtract 9. That's going to leave us 21 days for June. And then it was made on July 11th. So we're going to add 11 days to that. So 21 plus 11, 32 days later. Now we're going to do the same thing we did in the previous computation, except now instead of using 100 days, we're going to use 32 days. And the principal is going to be different now. The principal is going to be what we're left over from the previous computations. The principal is $33,569.44. $33,569.44 multiplied by 0.10, the rate hasn't changed, it's still 10%, multiplied by 32 days over 360 gives us interest that was accrued during that period of time of $298.40. So that's what's owed as of July 11th. The second partial payment is $3,500. We're going to subtract from that the amount that goes towards the interest, $298.40, and the remaining balance goes towards the principal. The total principal, as we left off from the last payment, was $33,569.44. We're going to subtract this portion of the principal, $3,201.60, and that's going to leave us $30,367.84. Now, so far, what have we used up? The first partial payment was made at 100 days. The second partial payment was made at 32 days. That's 132 days. So we're going to take the 180 for the total loan and subtract 100 and then 32. And that's going to leave us 48 days remaining from July 11th to the end of this loan. And from there now we can compute what the final interest is going to be to finish this off. So our balance at July 11th is $30,367.84. That's what we're starting off with. We're going to multiply that by 10%. And now we're going to multiply it by 48 days remaining divided by 360. Between July 11th and the end of the loan, she will accrue another $404.90. That's the interest that's going to be accrued for that period of time. And then we're going to take that and add it to the balance at maturity, or the $30,367.84. That's the balance that as of the last payment. We're going to add the $404.90 to that $30,367.84, and that's going to give us an amount due at the maturity of $30,772.74. This is what the textbook got wrong in the previous problem. They didn't add it; they subtracted. That's it needs to be added. So this is correct. Now you can actually draw up a little amortization schedule that shows exactly how this all works. With the June payment, the total amount of the payment was $6,000, of which $1,069.44 applied towards the interest, and $49.30.56 was applied to the principal. So the total balance at that time left, what was the total loan amount? $38,500. $38,500. We subtract the $49.30.56 is $33,569. We actually did that earlier, but this is just a way of putting it into a table that makes it easy to see after every payment what the balance was. July 11th, $3,500 was paid. We computed that the interest was $298.40. The balance then gets $32,01.60 is applied to the principal. $33,569.44 minus the amount applied to the principal gives us $30,367.84. And then at maturity, we have the amount that, well, we had to compute this, $30,772.74. That was the amount of the payment. You got an extra E there too. We're going to add $404.90 to that. So the total amount is $30,367.84 that was applied to the principal. And that leaves a balance of 0. There is a rule of 78 when prepaying loans. The variation of the United States rule called the rule of 78 is still used by many lenders for installment loans. This rule allows a lender to earn more of the finance charge during the early months of the loan and compared with the United States rule. Lenders typically use this rule to protect against early payoff on small loans. Effectively, the lender will earn a higher rate of interest in the event of an early payoff. All right. So the rule 78 gets its name based on the loan of 12 months. The sum of the months is 1 plus 2 plus 3 all the way through 12 gives us 78. The finance charge for the first month is 12/78 of the total charge, then 11/78 of the second month, and 10/78, etc. The rule 78 can be applied to loans with terms other than 12 months. For example, the sum of months in 6 months is 1, 2, 3, 4, 5, 21. So then the finance charges would be computed as 6/21s, 5/21s, 4/21s, etc. So here's a chart that will help you make it easier for you to see the 12 months, how it rolls all the way through for 12 months and then for 6 months. Now another formula we can use to finding the unearned interest. The unearned interest, U, is equal to F. F is the finance charge multiplied by N over P. N is the number of payments divided by the remaining payments. And that is going to be multiplied by 1 plus N divided by 1 plus P. Just memorize the formula, or you don't even have to memorize it. It's a lookup. So. Aaron Ortega borrowed $6,000, which he is paying back in 24 months monthly payments of $295 each. With 9 payments remaining, he decides to repay the loan in full. Find A, the amount of unearned interest, and B, the amount necessary to repay the loan in full. Use the rule 78. So we'll go through this process. We'll go through finding the unearned interest by using the formula U equals F N over P 1 plus N divided by 1P. All right, so the unearned interest is going to be computed by taking the F, the finance amount, finance charge. Well, before we do that, we need to figure out what the finance charge is. So the total number of payments that are going to be applied to this, it is a 24 monthly payments of $295 each. 24 times 295 gives us $7,080. That is our total number of payments. Now that we know that, then we can come up with the finance charge by taking the total amount of payments and subtracting from that the amount that was borrowed. The amount that was borrowed was $6,000. $7,080 minus the $6,000 gives us $1,080. This is the finance charge. This is equivalent to the interest that he's paying for this loan. So using this formula, U equals F. Now we have F. F is 1,080 multiplied by N. N is 9. Where did 9 come from? So the number of payments is 24, and the loan is paid off with 9 payments left. How did we come up with that? With 9 payments remaining. It told us that, with 9 payments remaining. So 9 payments remaining divided by the total number of payments, P, that's also given 24. 9 over 24 multiplied by 1 plus 9 divided by 1 plus 24, NP. If we compute this out using the calculators, we'll come up with $162. When Ortega decides to pay off the loan, he has 9 payments of $295 left. Summing the remaining payments, 9 times 295 is $26.55. Using the rule of 78, we can then compute how much the payoff is. So $26.55 minus 162, which is what we came up with on unearned interest. On the day that we want to, on this day, with 9 payments remaining, he could pay this off by taking the $26.55, the total number of payments that are remaining, and minus the 162, which is the unearned interest, and that means he could pay off it with a $2,494 payment. Okay, moving on to the next problem. The Smiths borrowed $1,200 for a new washer and dryer and agreed to make 18 monthly payments for $74.30 each. After the 10th payment, they pay the loan in full, find the amount of unearned interest, and B, the amount needed to repay the loan in full using Rule 78. I'm going to go ahead and skip this because this is really the same problem we did before with different numbers. So I'm sure you can kind of work through that. That concludes 12.3.